Hey guys, so this is the 2.4 notes day 2, where we're going to take a look at completing the square when a is not 1. So for the first one, this solving question, it says solve for x by completing the square. We actually took a look at one like this yesterday, it was in your homework. But whenever you're doing a solving for x and the a value is not 1, here it's 2, all you have to do is, whether it's a GCF or not, you're just going to divide the 2 out of everything. And what this is going to do is, right, if we divide the whole left side by 2 and the right side by 2, our equation's still balanced. So what this effectively is going to do is it's going to get rid of that 2. And because we're taking 0 and dividing it by 2, it's just zeros out, right? So then on the left side, we're going to have x squared minus 3x plus 7 halves. Now that our a value is 1, we can just take this x squared and we can just do the completing the square process. So I'm going to have -3. I'm going to cut it in half, right? And then I'm going to square that value. So that will give me 9/4. And that's what I'm going to plug in for the completing the square. So we'll go x squared minus 3x. And then here we go. We're going to complete the square. So plus 9/4 minus 9/4. And then we can add that 7 halves back in and then say it's equal to 0. And then the reason we do that is so that this perfect square trinomial gets made, right? Which is easy to factor. We're just going to say x minus 3 halves squared. And hopefully remember that minus 3 halves is the same as our b divided by 2 value. So those should always match. For the last part of the completing the square process, we need to combine the negative term with this 7 halves. So let's change halves so that we can get it into fourths. So we need to multiply by 2 over 2. So that will give us positive 14/4. So we're going to go -9/4 plus 14/4, right? So that's going to give us positive 5/4. And then that is still equal to 0. And then to finish this question, we'll add the 5/4 to the other side, right? We just need to solve for x, so we need to isolate x. So we'll subtract 5/4 from both sides. Work up here. That'll give us x minus 3 halves squared is equal to -5/4. Square root everything. So we get x minus 3 halves is equal to plus or minus. And then this negative sign is going to come out of the radical. It's going to become I. And then we're going to have a radical 5. And then radical 4 down here in the denominator is just going to become a 2. Okay, because the square root of 4 is just 2. So then we add the 3 halves to the other side. And we get x equals 3 halves plus or minus I radical 5 divided by 2. And then this would be our answer. So once again, the nicest part about solving is that this a value just goes away when you divide everything by 2. And you'll be able to do solving questions like this every time. Just divide whatever is on a off of it. It gets a little bit different when you try to convert to vertex form by completing the square. So like in this next question, the process is going to start the same, but our a value just doesn't quite go away right off the bat. So instead, we're going to divide everything by 0.065. I'll just write 0.065, 0.065, 0.065. And then we're also going to divide this y by 0.065 as well. So exactly the same as we started the last question, just the only difference is y divided by 0.065 doesn't let that 0.065 go away. So now what we're going to have is x squared. So let me go 3.7 divided by 0.065. That gives us positive 56.92x. And then 12.5 divided by 0.065 gives us negative 192.31 is equal to y divided by 0.065. And we need to keep this throughout the problem because at the very end, for it to be in vertex form, we're going to have to move that 0.065 back to the other side. But the reason we did this was so that our a value was 1, and now we can do the completing the square process here. So we're going to take 56.92, and we're going to divide it by 2, which gives us 28.46. We take that 28.46 and we square it. So if we times 28.46 by itself, that's going to give us 809.97. And that's what we'll fill in the completing the square with. So we have x squared plus 56.92x, and then we'll say plus 809.97 minus 809.97, and then that minus 192.31 will also drop. 192.31 is equal to y over 0.065. Now we factor this. So we factor this out. It's going to leave us with x plus 28.46 squared. Again, that 28.46 is just b divided by 2. And then we'll go negative 809.97 minus 192.31. That gives us negative 1002.28 is equal to y over 0.065. And then finally, we can multiply 0.065 to the other side. So we're going to multiply this by 0.065, and we're going to multiply this by 0.065. So then in the end, we have 0.065, and then we have x plus 28.46 squared. And then that times 0.065 is going to give us negative 65.15, and that's equal to y. And there it is. That's vertex form. Decimals aren't the most beautiful thing. All right, we'll take a look at one without decimals in this next problem. But I just want to show you that the process is the same every single time, whether there's decimals or not. So this question right here, again, same idea. Can't do completing the square because a is 3. So instead, we're taking everything divided by 3. X squared minus 2x minus 2/3 is equal to y over 3. And then we do the completing the square process, right? So negative 2 in half is going to be negative 1. Negative 1 squared is positive 1. So we have x squared minus 2x, and then we're going to say plus 1 minus 1 minus 2/3 equals y over 3. This section will factor, right? X minus 1 squared. We need to change minus 1 into thirds so that we can minus the 2/3. So we're going to take this and multiply it by 3 over 3. So this is negative 3 over 3 minus 2/3 is equal to y over 3. And then now we just combine those fractions. So x minus 1 squared, negative 3 minus 2 gives us negative 5/3 equals y over 3. And then multiply the 3 by everything to put it back into the equation. So 3x minus 1 squared minus 5 is equal to y. And there's your vertex form. Okay, that is really it for the notes for today. Okay, this last question down here that says bonus. All right, I'm just giving it to you a couple days in advance so that you can try it. There's some sneaky algebra things that happen in this problem, okay? But when you work through it, what should happen is you should get out the formula is the quadratic formula. All right, so let me know if you have questions on any of this, and give this last problem a shot. It's just solving by completing the square. And you can ask me about it in class if you want to. But yeah, hope you guys have a great day.